Hi, this is Jason Gorman from Codemanship with the final in our series on solid design principles. The D in solid stands for dependency inversion. High-level modules should not depend on low-level modules, and both should depend upon abstractions. Also, abstractions should not depend upon details. Details should be depending upon abstractions. Let's look at a little example here. We've got a response writer class here that chooses a particular kind of concrete serializer to serialize a customer, depending on what response kind is selected, whether it's HTML or the default of XML. Now, the problem here is that our response writer, which is a high-level module, is depending on the details of which particular concrete kind of serializer to use. So what we want to do is we want to turn this dependency upside down so that response writer depends upon some kind of serializer abstraction, which we're going to extract now. If we go into our HTML serializer, the first thing we need to do is make HTML serializer and XML serializer identical in terms of their interfaces. So they need to have methods with the same signatures. That's quite easily done here. We just rename. So we have a generic serialize method there that takes a customer, and an XML serializer, we rename that so that it has the exact same signature. As for HTML serializer, once we've done that, I should just mention, by the way, I'm running JUnit Max in the background here, so the tests are being run as each refactoring completes. Okay, so what we're going to do is we're going to extract an interface from here, which we'll just call customer serializer, and it's the serialize method that we want to extract. Okay, looking okay, and then we make it so that our HTML serializer also implements the customer serializer interface. So we've created our abstraction shared by HTML serializer and XML serializer, and we want to rewrite the response writer so that it depends upon this abstraction rather than the concrete classes. What we can do here is we can do a little bit of jiggery pokery. If I introduce a local variable, let's make it of type customer serializer. Let's just make that null by default. And then we call serializer.serialize at the bottom here. And this is currently, of course, unreachable. So what we need to do is we need to change the code here so that instead of invoking this method, we're just choosing the appropriate serializer. Would help if I spelled that correctly. And the same here. Okay, and we need to return a value, obviously. So now our if statement there, all it does is it chooses which kind of serializer to use. The invocation is actually on the interface that we've extracted. Now what we could do is we could extract this block of code into a factory method, and that would remove knowledge of which kind of serializer is being used from createResponse, but it would still be inside the response writer class, so we would still have a high-level module that depends on lower-level modules. What would make more sense if instead of passing in a response kind enumerator value, we could replace that type code with the right implementation. So essentially what we're doing is we're replacing the type code response kind with a strategy for serializing customers. So what we can do is we can change the signature to begin with of this method so that this now serializer now becomes a parameter. So let's add the parameter to customer serializer. We'll give it a default value of null to begin with. Okay, now that's going to play havoc because we've already got a variable called serializer. We can get rid of that line. So now we're referring to the parameter value. Let's save that again. JUnitMax is telling us that our tests are passing. That's good news. So now it's up to us. If we were to get rid of this so that we're just passing in a serializer, and then we go to our test here and we let the client decide beg pardon, the response writer test here. So this client code, which in this case is test code, decides what kind of serializer to use. Instead, no, that's not what I wanted to do. Let's go back there. Mutual serializer. All fingers and thumbs today. Okay, and instead of passing in null here, we pass in an XML serializer. Okay, so now when I save this, these tests should pass. And they do, because the right kind of serializer is being decided by the client code. And the high-level module, our response writer, has no knowledge. We can now remove this redundant parameter here. It's no longer being used. We save all the code, all our tests are passing. So now our response writer has no knowledge of the concrete kinds of serializers, the XML serializer and the HTML serializer. It's a high-level module that depends upon a single abstraction. So that's one example of dependency inversion. There are many more, of course. Now, there is an interesting question here just before I sign off. If we look at our customer serializer interface, which is an abstraction, it depends upon customer. Now, customer is a concrete class. It's not an abstraction. So we have an interface that depends upon a concrete class. Now, I'm quite happy with this, actually. I don't think this is too much of a problem because it is a customer serializer. But if we were to have different kinds of serializers for different kinds of domain objects, say customer, invoice, account, so on and so forth, we may want to extract an abstraction for these domain objects, for example, an entity interface or a domain object interface, and then have our serialize a serialize interface that accepts a domain object as a parameter. Anyway, that's dependency inversion. Those were the S.O.L.I.D design principles. I hope it's been of some use, and I thank you.